Alright, so today we are going to look at the chemist's way to represent concentration, and that is with our good buddy the mole. And that, well, the chemists use is called molarity, and we use a capital M as the unit. And what it is moles of solute per liters of solution, moles per liter. And it is liters of solution, overall total solution, not just the liters of the solvent. So make sure you make note of that. So what we're going to do here is look at a couple different ways we can use this expression to answer some questions. So first up, we got a nice simple question. What is the molarity of a 5-liter solution that is made with 20 moles of glucose? So I just simply need to compare moles per liter. So 20 moles divided by 5 liters, and I get 4 molar, capital M again. But that's how I express that concentration. That is a 4 molar solution. But of course, in the lab, we don't measure directly with moles. We are constantly using grams. So here we have a more relevant question, if you will. What is the molarity of a 5-liter solution made with 2,700 grams of glucose? And you'll see now that I included the formula for glucose, C6H12O6, and I have a little reminder question there like molar mass, because I'm pretty sure you remember that we're going to need the molar mass to convert from grams to moles. So when I go to the periodic table, 6 carbons plus 12 hydrogens plus 6 oxygens, that adds up to 180.0 grams per mole. So that's what I'm going to do first. I'm going to take the 2,700 grams and divide by the molar mass, and I see that there are 15 moles of glucose in this solution. So now I can simply do what I did before and have moles divided by the 5 liters, and this is a 3 molar solution, 3.0. with the correct sig figs here. Another way that we can look at that same question kind of is, using grams, is this type of question. How many grams of glucose are left if 5 liters of a 2.2 molar solution of glucose evaporates? So if the water evaporated away, the glucose would be left behind. And we'll also do several questions solving this way, like how many grams of stuff are we going to need to make a solution? So this is a very important type of molarity question. But again, you see that I give you the formula for glucose, and again, the molar mass is going to be 180 grams per mole. But this time we won't need that information until the end. So the first thing I do is look at what I know. I know the molarity, 2.2, and I know that I have 5 liters of solution. I don't know the moles, which will take me to grams. So when I multiply 2.2 times the 5.0, that will show me that there are 11 moles of glucose in this solution. And then, of course, to go from moles to grams, I need to multiply by the molar mass. And when I do that, it shows me that there are 1,980 grams of glucose that would be left behind if that solution evaporated. And again, this is how we will work a problem when we need to know how many grams of solute that we'll have to measure out in order to create a proper solution in the lab, which we'll be doing later this week. Alright, the last part of this that we're going to look at is making dilutions. And oftentimes I need to dilute chemicals down before I give them to you in the lab. And when I do, I use this formula. M1V1 equals M2V2. It looks very similar to some of the gas law equations like Boyle's law. M, capital M, of course, is going to be a molarity. V, as before, is still volume. And the 1s represent our stock solution, which means the very concentrated solution. And the 2s represent what we're diluting to. And so here's the little question that's posed to you. If I have 12 molar stock hydrochloric acid and I need to make 1500 milliliters of a 4 molar hydrochloric solution for lab, how am I going to do this? Well, I'm going to need this equation, and I'm going to have to plug the numbers in the right spot. So again, the ones are for the stock concentrated solutions. So M1 is always bigger than M2. The other thing I look for in the problem, you can see I highlighted it yellow, is the word of. 1500 milliliters of 4 molar solution. That means that those two numbers are going to go together. So when I plug the numbers in the right spot, 12 is my concentrated molarity. How much of that I need is what I'm solving for, V1. My diluted molarity is 4 molar, and I need 1500 milliliters of that. So you see the two numbers together. So 12x, 12V1 equals 6,000. I divide by 12, and I end up with 500 milliliters. Well, that's great. That's the math. Well, if someone said, if I left directions and I just say 500 milliliters, that doesn't tell me how I do that. So what I need to do is add a little clarification sentence. So yes, that's the math that I needed. I know that I do need 500 milliliters of my concentrated stock solution, but what am I going to do with it? And so I say this. I'm going to take the 500 milliliters of the 12 molar HCl and I'm going to dilute it. Of course, I'm going to dilute it with water. How much? 1,000 milliliters. Where did that come from? Well, if you remember back in the problem, I needed 1,500 milliliters of the solution. So if 500 is the stock, the rest, the 1,000, is water. Alright, so that's our good buddy Molarity. We'll be doing lots of problems with him over the next several days, and I'll see you later.